Section 8.1 Complex Numbers. In this section we introduce complex numbers. Possibly some of you have seen that before. What are complex numbers? Before we get into that one, before when we learned in other parts in algebra, let's say someone asks you the square root of 16, you would say it's 4 because 4 times 4 is 16. But then when we get to the point of someone asks you what's the square root of -9, then you can't find two real numbers, their product is -9. So the largest set that we've known so far is the set of real numbers. Mathematicians found a new set. It's called the set of complex numbers. And that's a bigger set than the set of real numbers. So the question is, how do we handle this? How they introduce this, we start with the definition. So by definition, we're going to have, we call it the imaginary. So they had to introduce like a new tool here. Imaginary unit or number, we call it either unit or number. I is the first letter of the word imaginary, is defined as, we define it as I square equals -1. Very important. I square equals -1. So why does that help us? Because now if I have something the square root of -b, then what that negative does, we can rewrite the negative as -b as -1 times b, and that gives us, you can replace the -1 with I squared times b. Now we are able to simplify this by taking the I squared out as an I, and the b stays inside. B is a real number. So now with this bigger set, basically we have more tools now to help us to find what's the square root of -9 is. Now we can simplify it over the complex numbers. I can simplify what the square root of -9 is. So always that negative, you can take it outside as an I, square root of 9. But square root of 9 is 3, so that turns out to be 3i. The next one, the square root of negative, let's say 19, just -19. Again, we take the negative outside as an I and 19 stays in. But 19 cannot be simplified, so we just keep it as is. The next one, -24, the square root of that. So we can take the negative outside as an I, and the 24. Can we simplify 24? Well, it's 4 times 6. The 4 comes out as a 2i square root of 6. So you have to simplify to the maximum you can, the max. Next one, let's look at another example. What about if we are asked to find the square root of -8 plus the square root of -18? So what do we do here? We take the negatives outside as an I first. That's the first step. And then this one is I square root of 18. Then the 8, you can write it as 4 times 2. 4 times 2. 18, I can write it as 9 times 2. So let's see what that gives us. That's, you take the 4 outside as a 2 and keep the other 2 in. The 9 comes out as a 3 and keep the 2 in. But notice these two are the same. Like you can combine them because they have same radical. Same radical here. So we can combine this and this. That's 5i square root of 2. 5i square root of 2. That's introduction to complex numbers. How complex numbers started to help us simplify the negatives under the radical sign, like the square roots or any even index. You don't need to worry about that part, but let's say radicals here for this time. Also, from before, we are able to multiply the square root of a times square root of b and do as this is a times b. This works only under the condition if both a and b are bigger than or equal 0. If at least one negative, we can multiply. That's what the property says. So what happens if in case we are asked to multiply -9 the square root of -25? So does that give us? I square root of 9 times I square root of 25. So what does that give us? 3i times 5i. That's a 15i squared. and that gives me negative 15. So note, I'm going to write it as a note here. If you have negative 9 times square root of negative 25, this does not equal negative 9 times negative 25. You will get a different answer. These are totally different things. So that's a this is a false introduction or false process or step. Now we can, with the I, having I in there, so I motivates us to introduce what a complex number is. So a complex number, we define it as, complex number is any number written in the form z equals a plus bi, where a and b are real numbers, and I squared is negative 1. Note that a, specifically a, is called the real part of z. B is the bi is the imaginary part of z. Examples on this, it could be, let's say, like 3 plus 2i, or negative 1 plus I, or 1/2 minus 3/4 I, or 7i. Even if there's radicals like 2 plus 5 square root of 5i. Even if you write 8, 8 is can be written, this is a complex number because you can write it as 8 plus 0i. That's another complex number. So these are examples of complex numbers, and these numbers that I wrote here, if you notice, I wrote all of them in the form a plus bi. So note that this form a plus bi is called the standard form of a complex number. So always, if you write this way, a like some number plus some number I, that's standard form of a complex number. Two complex numbers. Let's say z1, let's call it a plus bi, and z2, c plus di are equal if and only if two numbers are equal, if and only if the real part equals real part, so a equals c and b equals d. These two things, they must be the same. So z1 equals z2 if a equals c and b equals d. That's important. How to apply this? Let's say we're asked to find a and b if 3a minus 7 plus 3i equals 8 plus 2 minus bi. So how do we find that out? So to do this, these two complex numbers are equal. So what we can do here is we can set the real part equals the real part and the imaginary equals imaginary. So 3a minus 7 equals 8 and the 3 equals 2 minus b. That's because they are given to us as they are equal complex numbers. So now from the first one, we can say 3a equals 15 by adding 7 to both sides, and a would be 5 in this case. From this one, you can subtract 2 on both sides, get negative b, and therefore b is negative 1. So I got a and b values that we are looking for. Now, what other things good to know about complex numbers? One of the things is, how do we perform some operations? What are the operations that we can perform in complex numbers? We can perform addition, subtraction, multiplication, and division. That's what we're looking at now. So let's say we are asked to perform addition of two complex numbers, like this one plus negative 4 minus 11i. So how do we perform this? Well, let's keep the first one the same. This is minus 4 minus 11i. This is negative 6 minus 8i. So what you do, you just combine like terms. So it's kind of like, think about I as an x. So you add the numbers together and the x's together. And then notice how I wrote the final answer in a standard form, a plus bi. So here we can say write final answers in standard form. Other examples, let's say we have negative 1 minus 5i minus 4 minus 3i. That's another example. So what do we get here is there's nothing in the front of the parentheses, so we can just bring this down. But here I have a negative. Negative means negative 1. You need to multiply by the first one and negative 1 by the second one. It becomes minus 4 plus 3i. And then minus 1 minus 4 is negative 5. And this with this is minus 2i. Other example, let's say 5i times 2 plus I. So how do we do this? We multiply this out and get 10i plus 5i squared. It's not done because I do know what I squared is. It's a negative 1, so that gives us minus 5. Is the answer in standard form? No, but we can rewrite it as negative 5 plus 10i. Negative 5 plus 10i. Number 4. What about if we are asked to do 2i squared? And then we're going to look at negative 7i squared. And after we finish that, we are going to look at 6 minus 3i times 6 plus 3i. Let's look at the first one. This one, when you square, you don't only square the 2 or only square the I. You have to square each one of them. So that gives us 4i squared. And the I squared is negative 1, so the answer is negative 4. Same thing here. You're going to square the negative. That becomes positive. Or you can do like this times I squared. That's a 49 I squared. But I squared is negative, so that gives us negative 49. For this one, this you can multiply it out, or which we recommend, you know this, this looks like a minus b times a plus b. We can review the concept for this. That's a squared minus b squared, like that. So you take the first one, you square it, minus the second one, square it. Difference of 2 squares. So I can do that here. 6 squared minus 3i squared. Let's see what we get. 36 minus, similar to what we just did earlier, 9i squared. That's 36 plus 9. And that gives us 45. What about another one? Another one to do. That's now number 7. 2 plus 5i times 1 minus I. So what do we have here? We cannot use what we just did. So I'm going to multiply 2 by everything, by the first one. 2 minus 2 times I, 2i. 5i times 1 is 5i. 5i times negative is minus 5i squared. So that's a 2. And here, this is a 3i. Plus 5. So 2 plus 5 is 7 plus 3i. So 7 plus 3i. That's what we have here. So it doesn't matter what we have. Even if you have something in the front, you also multiply that out the same way as we just multiplied the other one. Now, another good thing to learn is how do we deal with powers of I? Powers of I, like really high powers of I. How do we deal with them? So let's say we're asked to find I to the 16th power. I to the 16th power. To do so, we always start with I squared. That's the trick. That's the key here. And then ask yourself, what am I going to put here on the top here? If I multiply it by 2, gives me 16. That would be 8. Right? 8 times 2, 16. So, but we know I squared is negative 1. So negative 1 to an even power is always going to be 1. So negative 1 to an even, any even number is 1. Negative 1 to an odd is always negative 1. Very important to know. What about if they give us another example? I to the 35th power. Like, let's make that number to be odd. So here I start with I squared. There's no number if you multiply it by 2 gives you 35. But I can get to 34 by doing 17. 17 times 2 is 34. If you want to get that number, you can always, if it's an odd, always do 1 plus what? 34. So what two numbers are product 34? Like 2 times what? So for 34, 2 times what number? Is 17, because you can divide 34 divided by 2 is 17. So that gives me 34. Then I still have one more copy to make it 35. So let's see, that's a negative 1 to 17 times I. Negative 1 to any power, to an odd power is negative 1 times I. So the answer is negative I. That's powers, no matter, even if it's I to 2079 or any power, it doesn't matter. It's always going to be the same. Also, since we were doing, I showed you the a square minus b square. This is called complex conjugate. In complex number, it has a name. It's called complex conjugate. So the conjugate, we say the conjugate of a plus bi is a minus bi. The conjugate of a plus bi is a minus bi. So if I want to take a plus bi and multiply it by a minus bi, let's see what we get. I see they look the same, so this is same as this and this is same as this, just the middle sign is different. As you can see, these two signs are different, opposite. So you always take the first one, you square it, minus the second one, square it. So what do we get? A square minus b square I square. Very important to know this. So what do we get? This stays the same. I squared is negative 1. By negative, that becomes positive. So that gives us a squared plus b squared. So if we are asked to find the conjugate, you don't have to memorize this formula up there, but just an application. Find the conjugate of each of the following. Let's say the first one is 5 plus I. Number 2 is going to be 3 minus 1/2 I. Let's see, how do you find the conjugate of the first one? All you have to do is take the same numbers, just switch the middle sign. Same numbers, switch the middle sign. And notice if you want to multiply them out, just in case, you can apply the one I showed you earlier. Take the first one, always square, minus whatever you have next, square. And that gives us in return 25 minus I square. But I squared is negative 1. By negative, that's a positive 1. So that becomes 26. And you can do the same thing with the other one. What about if they ask us for 7i? What's the conjugate of 7i? The conjugate for 7i is simply negative 7i. Negative 7i. You just switch the sign. If it's a plus, minus, minus, plus. And how do we use this? What do we need this for? Well, earlier we did addition, subtraction, and multiplication, but we didn't do division. So if we are asked to divide, let's say 8 minus I over 2 plus I. So divide, we need to do rationalizing here. It's called, the process called rationalizing. So we're going to multiply top and bottom by the conjugate of the denominator. So that becomes 2 minus I, 2 minus I, as you can see. So now we multiply top by the top, 8 minus I times 2 minus I, the denominator by the denominator. So let's see what we get. On the top we get 16 minus 8i minus 2i plus I square. And the denominator 2 square minus I square. So see how I'm using it now in the denominator? I don't have to multiply the entire denominator. I can just use it this way. So let's see. On the top, what do we have? 16. These two can be combined to minus 10i. And I squared is negative 1, so minus 1 over 2 squared is 4 minus I squared is negative 1. See what we get. 16 minus 1, I can combine them, make it 15 minus 10i. Denominator 4 plus 1 is 5. This is not in a standard form. So what we have to do is we are allowed to break this first one over 5, second one over 5. And this gives us 3 minus 2i. So that would be in standard form. So two things here good to know. If you have a plus b over c, you can always split it, a over c plus b over c. If you have a minus b over c, it's a over c minus b over c. So that's how we rationalize or divide. Divide means no I in the denominator. Rewrite it in this form, in the standard form. Another one, what about if they just put I down there? Do not split it in this case. If you split it, you still have I in there. So to rationalize this, we need to multiply top and bottom by the conjugate, which is negative I. Negative I. If you multiply only by I, some students ask that, that's totally fine too, so because the negatives cancel at the end, so we don't need that. So what we get on the top, 1 times I, 3I times I is 3I squared, and the denominator is I squared. So let's see, I minus 3 over negative 1. Now we need to split it up, I over negative 1 minus 3 over negative 1. That gives us negative I plus 3. But it still doesn't look like in a standard form, so you do 3 minus I. 3 minus I. One last example about this. Let's say write 4 over 1 plus I in standard form. That's another way to ask you. Write this in standard form. Here we cannot split. We can only split if you have something plus or minus something over one thing only, not over 1 plus something like this. So what we have to do in this case, we take it and multiply by the conjugate, which is 1 minus I. On the top we get 4 times 1 minus I, and the denominator, it's always the first one square minus the second one square. Let's keep the top for now the same. The denominator 1, I squared is negative 1. By negative become positive 1. So that gives us 4 times 1 minus I over 2. By 2, 1, by 2, 2. Multiply the 2's in, 2 minus 2i. That's the standard form of the complex number. Let's look at another example. Determine, if we're asked to determine whether 1 plus I root 3 satisfies the equation x squared minus 2x plus 4 equals to 0. Does it satisfy it or not? So what we do here is 1 plus I root 3 square minus 2 times 1 plus I root 3 plus 4 equals to 0. So we substitute that in and we're going to see, is that going to give us 0 or not? Well, if you forgot the formula for a plus bi, you can rewrite this twice as I'm doing now, because that's what most students do. But here you can distribute the negative 2. So negative 2 minus 2I root 3 plus 4. And then we're going to see if this is going to be 0 or not. Here, multiply it out. 1 plus I root 3 plus I root 3 plus I squared times 3. Minus 2 minus 2I root 3 plus 4 stays the same. Is that going to give us 0 or not? Well, let's see. This stays the same. Here, 2 copies, identical ones, so that becomes 2I root 3. The I squared is negative 1, that becomes minus 3. This and this combined to 2, and 2I root 3. Is that going to be 0 or not? Notice this cancels. And what we get? 1 plus 2 is 3, minus 3 is 0. So 0 equals 0. So yes, we can say that 1 plus I root 3 is or satisfies the given equation. Means it's a root. It's a root of that equation. What about other examples? Let's say they ask us to, for a real number y, multiply y plus 2i, y minus 2i. So how do we multiply that out? Well, let's see, you can distribute this out, or if you like, do you notice something? It looks like a plus b, a minus b, so it's a squared minus b squared. So that gives us y squared minus 4i squared. But it's not done because I squared is negative, so that's a positive 4, because negative times negative. Let's add more applications or examples. Let's say z1 is given as negative 1 plus 7i, z2 equals, this is just additional practice, and z3 is given negative 2 minus I. Find and simplify z2 times z1 minus z3. Okay, they give us three complex numbers. So the first thing you would do is substitute. Z2 is 3 plus 2i. Z1 is negative 1 plus 7i. There's a minus. This minus sign is very, very important that you open a parentheses around it or after that. And then insert the Z3 in here. It's very important because what this minus saying is saying take negative and multiply by all Z3. But a lot of students, they just multiply it by the first content of the form. So let's keep this the same. This stays the same. Multiply now the negative. That becomes positive 2 plus I. So this stays the same. This is 1 plus 8i. Now we can distribute 3 plus 24i plus 2i plus 16i squared. Let's see what we get. This stays the same. These can be combined to 26i. And this is negative or minus 16. So that gives us negative 13 plus 26i. See, notice how I wrote the final answer in a standard form. Very important. Any expression you are given to simplify in the complex numbers, you must answers in a standard form, which is a plus bi. A plus bi. And that simplifies everything out.